In this video, we're going to look at applying the properties of logarithms to assist us with solving logarithmic equations. So we're asked to solve the following. Make sure we name the log first. What that means is let's name the property that we'll be using with our logs. If I have log base 2 of 5 plus log base 2 of x equals log base 2 of 15. The first thing I want to address before we actually go into the right way to solve it is what not to do. You cannot cross out the logs. That is a mathematical mistake. It is not possible to do. What you are thinking when you are doing this is this concept we have learned, which says if I have a log on one side and the same log on the other, then I can cross them out and just work with the equation of the terms. The reason why you can't do this here is because there is not just one log on both sides. There is an addition of logs over here. So before we do this, we have to combine. I wanted to address that first because that's a very big mistake that is made by many students. Let's look at how we do this the right way. What I'm going to look at first is what's going on. My right side is perfectly fine. There is one log all by itself. So I am not going to change the right side. However, if I look at the left side, I see I have more than one log. So what needs to go through my mind is how am I going to combine them? If I am adding logs, that means, well, it's like adding exponents, which means I multiplied. And so what's going on here is we are looking at our product rule. So to combine them, what I do, combine them into one log, log base 2, of the product. So 5x. Now that I combine them into one log, log base 2 of 5x equals log base 2 of 15, I have only one log on each side. So now I can cross them off. And I get 5x equals 15. X divide both sides by 5 equals 3. And we always remember need to check our answers to make sure our solution works with our definition of logs. And we plug in 3. We're taking a log of a positive number, so it's okay. So our answer is x equals 3. Next, what I'm going to do is look at this example. Log base 5 of 16 minus log base 5 of 2x equals log base 5 of 2. I cannot cross out the logs. Before we do that, we need to combine, and that's the key concept. Before we crossed out the logs, we made sure we combined all the logs on one side. So how am I going to combine these? Well, I see I am subtracting logs. That's like subtracting exponents, which means I applied my quotient rule. So that's what I'm going to do. I'm going to combine them, log base 5 of 16 over 2x. The right side only has one log, so I'm just going to leave it alone. Log base 5 of 2. Now what I'm going to do is now that I have one log on both sides, I can cancel them out. That's the purpose of applying our properties of logs, is so we can get one log on both sides and then solve. So really the equation I'm working with is I can simplify 16 over 2x as 8 over x equals 2. I can multiply both sides by x to get it out of the denominator. And that's going to give me 8 equals 2x. Divide both sides by 2, and x equals 4. If I plug it back in, I can just verify that if I do 2 times 4, that's a positive number, and we're good. It meets our properties of logs, our definition of logs. So in this video, we looked at our product rule and our quotient rule. How do we know which one to work with? We need to have our properties of exponents memorized because logs are exponents. If I'm adding logs, that means I'm adding exponents, which means I multiply. If I'm subtracting logs, that means I'm subtracting exponents, which occurs when you divide. So it's your quotient rule. Before you cross out, you need to make sure you combine all the logs on one side of an equation.